नानक चिंता मत करहो, चिंता तिस ही होए. Oh Nanak, don't be worried. Waheguru will worry for you. Class 11 chemistry, we are going to discuss some basic concept of chemistry, some numerical problems of this unit. Now the numerical number 1.29 of the NCERT exercise, calculate the molarity of a solution of ethanol in water in which the mole fraction of ethanol is 0.040. Assume the density of water to be 1. Now we have given the solution of ethanol in water and the mole fraction of ethanol is given, and we know the definition of mole fraction. The definition of mole fraction for ethanol will be the number of moles of ethanol divided by total number of mole present in solution, and it will be equal to in the symbolic form as given in the next equation. And now the density of water is 1. It means the 1 ml water is equal to 1 gram. Now we will put the value for number of moles for water because we have no value for the number of moles of ethanol. Now number of moles of water will be weight in gram divided by molar mass. Weight, so we will assume here the volume of the solution to be 1 liter or 1000 ml. We will divide, it will become mass equal to 1000 gram divided by molar mass 18. It will be the mole fraction of water. And now we will solve this equation and we will get the answer. We will get the number of moles of, we will solve the equation for number of moles of ethanol, and we will get the number of mole of ethanol equal to 2.31 by solving this equation. Now next numerical is 1.32. Use the given data in the following table to calculate the molar mass of natural occurring argon isotopes. 3 isotopes of argons are there, 36, 38, 40. Molar mass and abundance is given. Some student was asking me in the class how to solve this kind of numericals. Percentage means out of 100. If we have 0.337% of 36 argon, it means it is out of 100, 337 gram. If the total is 100 gram, then we will get 0.337 gram. If it is 1, then 0.337 by 100. If its molar mass is 36.96755 gram, then it will multiply by this term as given, as shown in the equation. Now the molar mass is multiplied by percentage and divided by 100. Now in this way we will do for all the isotopes and we will get the isotopic molar mass. Okay, average atomic mass. Hanji. Now numerical number 1.3 is very tough numerical, you may say, of this unit. If welding fuel gas contain carbon and hydrogen only, burning a small sample of it in oxygen gives 3.38 gram of carbon dioxide, 0.690 gram of water and no other products. A volume of 10 liter measured as STP of this welding gas is found to weigh 11.6 gram. Calculate the empirical formula, molecular formula and molar mass of the gas. How will we solve this equation? First of all, we will write the equation for burning. Suppose we have the gas CXHY. Any gas, it will burn in air and we will get CO2 and water. What amount? If we take the standard, then first point is C is 12x plus H is 12x plus Y, and we will get 44 gram but it will not give the correct data because we can't balance this equation and stoichiometry will fail here. It will not solve this numerical due to this reason. Second is the burning. If we burn this gas, it gives CO2 and H2O only. It's given in the question. CO2 is 3.38 gram and H2O is 0.690 gram. And third information is given in the numerical that 10 liter at STP is equal to 11.4 gram. It's very important thing. We will use this term to solve the Numerical now 44 gram of CO2 contain how much of carbon? 12 gram. It is the standard. We know the formula of CO2. CO2 is the formula, carbon is 12 gram and O2 is 32 gram, and 44 gram of CO2 contain how much carbon? 12 gram. 1 gram will contain 12 by 44 gram of carbon, and we have given 3.38 gram of CO2. 3.38 gram will contain how much of carbon? It will be the 0.9217. Now similarly we will calculate the amount of hydrogen present in a given amount of H2O. We know the 18 gram of water contain 2 gram of hydrogen. 1 gram will contain 2 by 18, and we have given 0.69 gram. After burning the gas give 0.690 gram of H2O, and the hydrogen will be 0.076 gram. Now since the welding fuel gas contain carbon and hydrogen only, therefore the mass of the gas, the total mass of carbon plus total mass of hydrogen, that will be equal to 0.9984 gram. Now percentage of carbon, we will get the percentage. How will calculate the mass of carbon? Total mass multiplied by 100. Then the carbon will be 92.32%. Similarly, percentage of hydrogen, amount of hydrogen divided by total and multiplied by 100, which is 7.6% of hydrogen. Now the question becomes for calculation of empirical and molecular formula. Element, we have two elements, carbon and hydrogen. We have given their percentage as we have calculated. 92.37 is carbon and 7.68% is the hydrogen. The molar mass for carbon is 12 and hydrogen is 1. We get the atomic ratio, divide the percentage by atomic mass. It will come from carbon 7.68, and same for the hydrogen. And simplest ratio, we will divide the smallest term, all the term by smallest term. We will 768 is the same, 1 simplest ratio, simplest whole ratio number ratio will be 1 also, and the empirical formula will be C1 and H1. Empirical formula mass will be 12 plus 1 13 gram. Now how will we calculate the molar mass? We know 10 liter STP of this gas is found to weigh 11.6 gram. 1 liter 11.6 by 10, and we know that 21 mole of each gas contain at STP 22.4 liter. Now 22.4 liter will contain the weight multiplied by 22.4 liter, it will be the molar mass of the gas, that is the 26 gram. Now what will be the molar mass? We have calculated here. What will be the value of N? Value of N is the empirical formula mass, molecular formula mass. 26 is the molecular formula mass and 13 is the empirical formula mass. N is 2, and therefore we will have now the molecular formula of compound is C1H1 multiplied by 2, that is C2H2. Next numerical is very simple one based on the stoichiometry calculation. Calcium carbonate react with aqueous HCl to give CaCl2 and CO2 according to the equation. We have the equation CaCO3 plus 2HCl changing into CaCl2 CO2 plus H2O is the numerical number 1.35 of the NCERT book. What mass of CaCO3 is required to react completely with 25 ml of 0.75 molar HCl? Now let's solve this numerical. We will write the equation. The problem is that the standard is that mass of the CaCO3 is 100 gram. 100 gram CO3 by the standard 0.1 showing in green. 100 gram of CaCO3 will react with the, what will be the molar mass of HCl? 36.5 multiplied by 2, 71. We have the 100 gram of CaCO3 will react 71 gram of HCl. Now point number 2, we will have to compound the amount of CaCO3 that will react with 25 ml of 0.75 molar HCl. Now he has not given this amount in grams. He is just a simple numerical of stoichiometry calculation, but there is a small numerical in one numerical. Numerical in numerical is there. It is the small numerical for molarity. Let us solve this value 25 ml of 0.75 molar. It is the molarity. And what is the molarity equation? M is equal to weight of solute, molar mass of solute multiplied by volume of solution and multiplied by 100. As shown in the equation, we have the molarity equal to what is the molarity? 0.75 molar, and molar mass of solute 36.5 HCl. Volume is 25 ml, and we will get the W2 here. We will have to calculate the W2. In most of the numerical it is given, but is not given here. Then we will have to calculate. There is small numerical in this bigger numerical. Molarity equation we will apply here, and we will calculate the W2 here. W2 is come out to be 0.684 gram. Now numerical is very easy. We know we have given one thing and we have to calculate the other. The given is in left side. We will have to keep the thing which have to calculate on the right side. Now 71 gram HCl react with how much of amount? 71 gram HCl react with 100 gram of CaCO3. It is standard one. 1 gram will be 100 divided by 71, and 0.68 gram multiplied by 0.68 gram, we will have the answer 0.96 gram of CaCO3. It is the simple numerical, but there is numerical inside the numerical. Small molarity numerical is also there. Amount is not given, weight is not given. For HCl, it has to be calculated here. Now 1.36 numerical number, last numerical of the NCERT book. Chlorine is prepared in the laboratory by treating manganese dioxide MnO2 with aqueous hydrochloric acid. According to the reaction equation is given here. How many gram of HCl react with 5 gram of magnesium dioxide? Let us solve this numerical. It is a very simple numerical of stoichiometric calculation. We have given standard as per equation. HCl molar mass is 36.5 gram. Number of mole is 4. Therefore, total mass of HCl that will react is 147 gram. MnO2 having Mn have molar mass of 55. O2 have 16 and multiplied by 2. That will become MnO2 molar mass will be 87. Now we will solve this numerical. We will have to calculate. We have to calculate how many gram of HCl. How many means we will have to take the value of HCl from standard to right hand side, and the value of MnO2 toward left side. Therefore, mass of MnO2 is 87 gram of NO2. MnO2 react with 147 gram of HCl. 1 gram will 147 divided by 87 gram of HCl, and 5 gram as given per numerical we will have to calculate. We will multiply by 5 gram and we will get the answer 8.44 gram of HCl. Therefore, 5 gram of MnO2 will react with 8.44 gram of HCl. Thank you for watching.